Wait! Before we show you this stellar hit, we need to take a moment to understand why we're here. In the NFL, a single hit can change a game or a career. Behind every bone-jarring tackle lies an invisible force: physics. The difference between a highlight reel play and a career-ending injury? Mass, acceleration, and energy. Raw science playing out in milliseconds. Today, we're here to break down some of the science behind NFL collisions. How does a 300-pound lineman's tackle compare to that of an 180-pound safety? What makes some hits catastrophic while the others are just another Tuesday? And how do players and the league engineer safety into a sport with such force? I'm your host, Shane Davey, and with my compatriots, we intend to answer that question. I'd love to show you the aftermath of this, but first, we gotta start smaller. Take two players of the same size. Let's see what happens when they collide. This is Jack. Let's see what he, at 175 pounds, does when tackling Jackson, who's also 175 pounds. Jack crosses the span of 4.6 meters, or 5 yards, in approximately 1 second, meaning his acceleration is a blistering 9.1 meters per second, nearly matching the pull of gravity. To close this gap that fast, Jack has to exert 723 newtons of force. That's the equivalent of a strong man lifting up 160 pounds. The work being done here, 3,326 joules, which is enough to toast a slice of bread. At impact, the momentum shifts. Since these two weigh the same, they're going to move together, 4.6 meters per second, approximately 10 miles per hour. Impact force, 3,630 newtons. And the energy lost here, 1,663 joules. Converted into sound, grass stains, and maybe some mutual respect between the two. Equal mass, equal momentum. Physics doesn't play favorites here. Now we want to talk favorites. Let's up the mass index a little bit. This is Jack, again, and this is David. After delivering his little 723 Newton hit on Jackson, Jack thinks that his work's all done. But football is a game of momentum, physically and metaphorically. Again, with 1 second over our 5-yard or 4.6 meter distance, David accelerates to reach Jack in 1 second, requiring that average acceleration of 9.1 meters per second squared. Now to achieve this, David must generate approximately 744 newtons of force. At collision, David's momentum of 371 kilogram meters per second transfers to both players. Because their masses are nearly equal, they'll move together at about 4.3 meters per second post-impact. The actual impact force depends on the collision duration. The tackle lasts just 0.1 seconds. Jack would experience the average force of 3,720 newtons, comparable to the weight of a small car. This impact releases about 1,670 joules of energy, enough to potentially cause an injury without proper protective equipment. This demonstrates why proper tackling technique and safety gear are so crucial, even in a seemingly semi-balanced matchup. How'd that hit feel?
Yeah, it hurt.
And another key concept covered here by our hit friend.
Transfer of energy. It hurt.
Now let's take a look towards our main event. Some real mass hitting a rather smaller guy. This is me, or Shane, weighing in at approximately 300 pounds. This is, again, Jack, about to take a critical hit. Accelerating from rest, again covering the 4.6 or 5-yard distance in 1 second, meaning I am moving at 9.1 meters per second squared, as fast as gravity pulls you down. To reach Jack at that speed, Shane exerts a force of 1,244 newtons, like a small car pushing him forward. The work done, a whopping 5,689 joules. That's enough energy to power a light bulb for nearly a minute. At impact, my momentum transfers to Jack. Since he's lighter, we're going to go flying at 5.8 meters per second, or 13 miles per hour. The impact force, 4,584 newtons. That's like getting hit by half a ton of force. Where's all this energy go? Sound, heat, and a little bit of pain, with 2,096 joules lost in collision. To further show a similar demonstration, I also hit Jackson.
How would you describe your experience?
I'm still in pain like 15 seconds later, dude.
How would you feel? Was that like hitting a very solid object, or did you just?
We got a lot of distance there. It was very light.
All right.
It was like I just
all
kept
right.
running.
That's interesting.
But there's one more thing. What happens when you're the one tackling the 300-pound guy? We put David up to this test. Again, with 9.1 meters per second of acceleration, David strikes with a 744 newton of force drive. Upon his collision, he hits me with 3,720 newtons of force, like a Prius hitting a shopping cart. But I'm a lot bigger than, say, Jack was when David first hit him. So, what's gonna happen then?
It's like running into a brick wall with a mattress in front of it. There's some cushion there, but like not much. There was a lot of transfer of energy.
Now, you've heard this a few times now. Transfer of energy. So what does that mean? Well, when David launches his hit at me, he's not just delivering a hit. He's transferring energy. So where's that all go? Let's break that down. David accelerates at, again, 9.1 meters per second, which generates about 744 newtons of force. So his kinetic energy comes out to be 845 joules. Now, Newton's third law says this should be an equal and opposite reaction. So, when David transfers his energy towards me, due to my mass, I will rock back slightly while David takes more brunt force, backing up his claim of running into a brick wall with a mattress on top of it. What's the lesson here? Mass wins, almost always. So what is it that determines the outcome of a tackle? 3 key factors. Mass matters. A big lineman or linebacker is going to absorb a hit like a wall, while lighter players will resist becoming projectiles. Number 2. Energy transfers, but not equally. Force follows physics, but the body paying the price depends on who or what is bigger. And 3. Real-world consequences. From highlight reel stops to potential injuries, every collision is a balance of power and vulnerability. Football is a game of controlled collisions, where understanding the science doesn't just make us better fans, it reminds us why safety and technique matter as much as strength. So physics wins every snap. Play it smart.